Now we're going to practice graphing a quadratic with a leading coefficient. The math is still the same, but now we have to keep in mind that this x squared term has a coefficient. It's being multiplied by -2. So the vertex again is already done. The vertex here is at 211, and the rest of the inputs have already been found. So the first step I'll do again is graphing the vertex. So starting at 0, 0, going to 2, and then up to 10 and 11. From here, I'm also going to graph my axis of symmetry, just so that I have an idea of where my parabola is located. Okay, now, again, I need to find my additional outputs. So I need to figure out which half of the table I will plug in. My options are plugging in 1 and 0, or 3 and 4. I would rather deal with 1 and 0 because those will produce smaller numbers when I square them as opposed to 3 and 4. It doesn't matter which one you choose, both will work. So I'm going to choose to put in 1 and 0. I will always choose 0 if it's an option. So here we go, taking our function y equals -2 times 1 squared plus 8 times 1 plus 3. There we go. So we go in and we take this one step at a time. A common mistake is to multiply the -2 times the 1 before you square it. Remember, this is -2 times 1 squared. So if you want, you can put in a placeholder multiplication to remind yourself that you have to evaluate 1 squared first. So this is -2 times 1 squared is 1, and the rest of the multiplication, 8 times 1 is 8, and plus 3. Now that the power, this this 1 squared is simplified, now I can go in and multiply by -2. -2 times 1 is -2, plus 8 plus 3, and simplify from left to right. -2 plus 8 is 6, 6 plus 3, and my output here is 9. At any point, if you need to double check some of that math, feel free to use the scientific calculator. I feel pretty confident, so I'm going to write this as an ordered pair. I input 1, my output is 9. Moving over to substituting in 0, again, be careful with a coefficient. The math is always a little bit trickier. So -2, I'm going to put in a placeholder multiplication sign so that I remember to do the power first. -2 times 0 squared plus 8 times 0 plus 3. So -2 times 0 squared is 0. 8 times 0 is 0 plus 3. What's fun about 0 is 0 times anything is just 0. So that's 0 plus 0 plus 3. And that's just y equals 3. So I feel, again, pretty confident with my math there. So my input was 0, my output was 3. It's coming over to my table. My input was 1, my output was 9, input was 0, output was 3. So if I come down to the graph, now I can graph those points. 1, 9, 0, 1, 2, 3. So it looks like this graph is reflected. Let me try that again. This graph is reflected, and it looks like it's actually also stretched. It's moving much faster. Now, why is that? Because it's being multiplied by a -2. So when the leading coefficient is negative, your graph is going to reflect, and the vertex becomes what's called a maximum. If your leading coefficient is positive, the vertex will be a minimum because it'll be that U shape. All right, so now I can find my other output. So for the other side of the axis of symmetry, when x equals 3, that output will still be at 9. And when x is 4, that output will still be at 3. So I can come in here. And again, I feel pretty confident that this is, correct because it does have that parabola shape. So 9 and 3. If I wanted to just triple check that this was right, I could plug in 3 and 4 into my function and be sure. So -2 times, again, including parentheses, 3 squared plus 8 times 3 plus 3, and my output is 9. So I've actually confirmed now that substituting in 3 will produce 9. And then -2 times, again, including parentheses, 4 squared plus 8 times 4 plus 3, and the output is 3. So yes, I feel very confident this is correct. I checked all of my inputs, and my graph shows a reflected and stretched parabola. Now you get to choose whatever explanation you want, but this explains why I'm confident in my work. And this parabola has now been fully graphed.